In this facility, ordinary city trash is transformed into high-performance building materials. From the moment garbage trucks arrive at the gate, every kilogram of waste is tracked, controlled, and prepared for a new life as infrastructure. Every load is weighed and logged to control material flow and traceability. Automated systems record what comes in, where it goes, and how it will be transformed, ensuring consistent input for the high-tech process ahead. In the tipping hall, mixed municipal waste is unloaded into deep storage pits. Overhead cranes feed this chaotic stream into the first machines, turning a random mess of materials into a controlled and continuous flow. A controlled conveyor feeds waste to a powerful primary shredder. Here, large bulky items are ripped into smaller pieces, making the material easier to separate, clean, and convert into uniform building components. The rotating trommel screen separates the shredded waste by size. Fine material falls through, while larger pieces move forward. This step prepares the stream for more precise separation technologies downstream. Air classifiers separate light plastics and films from heavier fragments. By using controlled airflows, the system gently lifts light materials while heavier pieces drop, creating cleaner streams for specialized processing lines. Powerful magnets and eddy current separators pull out ferrous and non-ferrous metals. These metals are sent to dedicated recyclers, while the remaining mostly plastic stream continues its journey toward becoming new infrastructure. Optical sorters use high-speed cameras and sensors to recognize different plastic types and colors. Air jets redirect each piece into the correct stream, producing clean plastic fractions ideal for high-value building materials. Even with advanced machines, human eyes provide a final quality check. Workers silently remove any remaining contaminants, ensuring that only clean, recyclable plastics move forward to become structural materials. Sorted plastics are compacted into dense bales and fed into a dedicated processing line. From this point on, the factory focuses on plastics as a raw material, turning them into engineered components for construction. In the secondary shredder, plastics are reduced to small flakes. Controlled cutting and screening create an even particle size, which is essential for uniform melting, mixing, and strength in the final building products. Intensive washing and friction cleaning remove labels, food residues, and dirt. Clean surfaces are crucial so that the molten plastic can bond tightly with sand and other fillers, producing strong, durable infrastructure materials. Float sink tanks exploit density differences between plastics and contaminants. Valuable plastics float and are recovered, while heavier dirt and incompatible materials sink and are removed, raising the purity of the recycled feedstock. Mechanical drying and air classification remove moisture and dust. Bone-dry, clean plastic flakes flow smoothly, preventing blockages and ensuring accurate dosing when they are later blended into structural composites. In powerful extruders, plastic flakes melt and are filtered to remove any remaining particles. The result is a clean, homogeneous melt, an engineered raw material ready to be turned into pellets and then structural composites. Cooled plastic strands are cut into uniform pellets and stored in silos. These pellets provide precise control over mixing ratios, enabling predictable strength, flexibility, and durability in the construction materials we are about to create. To strengthen the plastic, the plant also recycles glass and concrete rubble into fine aggregates. These mineral fillers add rigidity, fire resistance, and dimensional stability to the final building blocks and panels. Computer-controlled dosing systems weigh plastic pellets, glass sand, and crushed concrete into exact recipes. By adjusting these formulas, the factory can create different products, paving blocks, wall panels, or structural elements. High-shear mixers and extruders blend melted plastic with mineral fillers into a dense composite. Every grain of sand and glass becomes locked in plastic, forming a strong, stone-like material ready to be shaped into infrastructure. The hot composite is portioned and distributed into precision molds. Automated gates and sensors make sure each mold cavity receives exactly the right amount of material, guaranteeing consistent size and weight in every block. After compaction, the fresh blocks are demolded and placed onto cooling conveyors. Controlled cooling prevents warping and internal stress, preparing each piece for final curing and strength development. In curing chambers, the composite blocks rest in controlled temperature and humidity. This finalizes their internal structure so they leave the factory dimensionally stable and ready to carry real-world loads. Every batch goes through strict dimensional and strength testing. Laser systems and lab machines confirm that these recycled blocks meet the same performance criteria demanded of conventional paving materials. Surface finishing adds grip and aesthetics, while printed codes identify each batch. Robots then palletize the blocks, preparing dense, uniform loads that are safe to transport and easy to handle on construction sites. Wrapped in tagged pallets move into a digitally managed warehouse. Every stack of recycled blocks is tracked in real time, so planners know exactly what material is available for upcoming infrastructure projects. From the factory, recycled composite blocks travel by truck into the city. Instead of ending in landfills, yesterday's waste now arrives at construction sites as a certified building material. On site, the old surface is removed and a stable base is prepared. Just like with traditional paving, proper ground and gravel compaction are essential, so the recycled blocks can perform reliably over time. Recycled composite blocks are laid on the prepared base and compacted with jointing sand. The result is a clean, even pavement that installs like conventional pavers, but is made largely from reclaimed waste materials